Okay, in this video, we're going to go through the review for 1-4 and 1-5. So the first question says, name 4 angles in the diagram using proper notation. Okay, so proper notation is going to mean that you're going to use 3 letters with the vertex in the middle. So I can see right away that B is the vertex of every single angle. So let's start naming our angles. So I'm going to do this top one first. So this angle right here. And that's going to be angle ABC. Or I could have named it angle CBA. And that's the same angle. Now let's do this one next. So that's going to be angle CBD, CBD. Or I could have called it angle DBC, angle DBC. So you don't have to have all of these down. You just want to have 4 different ones. That's why I'm writing them both ways, so that you can see that those 2 angles in the same color are actually the same angle. Okay, so then over here, let's look at that. That's going to be angle DBE or angle EBD. Okay, and then can we name any more? Let's see. What if I named, let's change my color. Let me name from here to here. So look what that angle is. That's going to be angle ABD. Okay, which you can also name it backwards as DBA. Okay, are there any other angles out there? I think so. How have I named, let's go with the gray color. What about this angle right here, which is CBE? So that could be angle CBE or angle EBC. And then what about the straight angle? So that's the ABE angle, which I could name it angle ABE or angle EBA. So what are you seeing for every single thing? So look at what they have in common. B is always in the center because B is the vertex. Okay, so you name angles using 3 letters. And you always put the vertex in the middle, and you put the angle symbol in front. Okay, so I just said you name angles using 3 letters. Well, there's always an exception to these things. Sometimes you can use only 1 letter. All right, you can't do it here. So this is going to be, can you name any of those angles B? And the answer is no, because B, or angle B, does not identify a, I'll say, precise angle. Okay, when could I use B? I can use B if I had this angle. Let's just say I have only this, all right? And I'll label that, I don't know, ZBQ. This one right here, I can call angle B because there is no confusion as to what angle I mean. Okay, when I say angle B, the only angle could possibly be is right there. If I try to say angle B for the other angles that we just went through, what would happen? Well, let me see if I can get this off. Hold on. Okay, let me get that off. Okay, so if you said angle B, I would not know what I meant. Did I mean ABC? Did I mean CBD? Did I mean DBE? Etc., etc. So you can only use 1 letter, and that 1 letter is the vertex, if and only if there is no confusion. And that's the scenario that I just did right here. This is the only time you can do that, when you have just a single angle, no combined angles. Okay, so that's an important point. Okay, so let's continue reading. So it says in the diagram, BD bisects angle ABC. Okay, so there it is. It's bisecting it. So this right here is the bisector. When you have a bisector, it divides that big angle into two equal parts. And that means if this one is 40, then this one has to be 40. All right, because they have to be the same. So they want me to figure out what x is. Well, I just made this connection, so now let's write that out. I know that 40 is going to equal 20 plus 4x, because each angle has to be the same because of the presence of the bisector. So subtract 20 from each side, and that's going to give you 20 equals 4x. Divide by 4, and I get x equal 5. And that's what they want right here. Now they want me to give them the angle measurements. So CBD is that lower angle, and I know it's 40. I could have plugged in the 5, right, and gotten 20 plus 20 equals 40. That's another way to use your x to get your angle. Okay, then they want ABC. Look at what ABC is. It's the big angle. So you're going to take 40 degrees plus another 40 degrees, and that's going to give you 80 degrees. That's the big angle. So my advice on these kind of problems is the following. Make sure that you are reading the information. Okay, that fact that that's a bisector is huge. Then make sure that you're figuring out, they told you to solve for x, and then solve for these two angles. Look at your diagram. Make sure you know what the angle is they're speaking about. Okay, don't guess what it is. Look at it and make sure it matches up. All right? Okay, let's move on. Oh, it says angles are classified as acute, right, obtuse, and straight. Okay, so let's talk about what that means first off. So acute, if it's acute, whoops, sorry, may not do that in marker. If it's acute, that means it's less than 90 degrees. If it's right, it equals 90 degrees. If it's obtuse, it is going to fall, this angle x will fall between 180 and 90. And if it's straight, it will be exactly 180 degrees. Okay, so look at these angles. I had a 40-degree angle, another 40-degree angle, and an 80-degree angle. All of them are less than 90, so therefore every angle that I just talked about is going to be described or classified as acute. Okay, so then I ask you to measure it again. They ask you to classify it, to key in on the words that they're asking you to use. They're right here, and that's a classification. All right, moving down to this next page. Now, I put all kinds of good information here for you to look at. So let's talk about that in just a sec, for just a second. Okay, in this first box, so this box right here, this is where we're going to look at complementary angles, and they're going to remind us that complementary angles could be next to each other. That makes them adjacent. Okay, so this is adjacent, or they could be not touching. So adjacent means they share a common side. So angle 1 and 2 share a common side. Angle 3 and 4 are not touching. Therefore, they do not share a common side. So they're non-adjacent. Complementary means they have to add up to 90 degrees. So complement means 90 degrees. You need to memorize that. Notice that they're indicating it's 90 degrees by this little box right here. Okay, so be aware that that's how they're going to tell you that they are 90 degrees. And since they put another ray through it, they cut the 90-degree angle into two complementary adjacent angles. I don't know what they measure, but I know if I add angle 1 and angle 2 together, I will get 90 degrees. Just like if I add angle 3 and angle 4 together, I will get 90 degrees as well. Okay, because they are complementary. Okay, so then let's move on to supplementary. Supplementary also happens when two angles add up to something. The something for supplementary is 180 degrees. So that means that supplementary angles, when they are adjacent, they're on a straight line or a straight angle. So when they're not adjacent and they're not sharing a common side, then they will simply add up to 180. Okay, when they share a common side, they're going to appear on a straight angle. And you know that straight angles are 180 degrees, and therefore angle 5 plus angle 6 is going to equal 180. So you want to definitely know that. Okay, there's a couple of other things down here that are important to keep in mind. Here I have two adjacent angles on a straight line. They are supplementary, and because they're on a straight line, they can also be called a linear pair. Okay, two angles on the same line. So I also know that angle 1 and angle 2 are supplements. Okay, so that brings us back up to this little box. The green, that's a straight angle, but now I also have learned that those are a linear pair because they are drawn adjacent on a line. Okay, another confusing thing that we want to absolutely clarify is the concept of vertical angles. So if you have a ray and an opposite ray and another ray and its opposite ray, they're going to form vertical angles. So angle 5 and angle 4 are vertical. Angle 5 and angle 4 are vertical. What else is vertical there? Angle 6 and angle 3. Angle 3 and angle 6 are vertical. You can walk right across the vertex to enter the angle. Key things about vertical angles are congruent. So angle 4 and angle 5 are congruent, and then angle 3 and angle 6 are also congruent to each other. Okay, so all four angles aren't equal, but each pair of angles are equal. All right, so now let's use this information to answer the next few problems. Okay, identify if angles are complementary, supplementary, or vertical, and then find the x. We've got two things going on. Okay, so these two angles are on a straight line. They are supplementary. They sum to 180. And therefore, to get the missing x, I'm going to subtract away 118. I'm going to borrow from the 8, making that a 7. 10 minus 8 is 2. 7 minus 1 is 6. And that's all she wrote. So it's 62 degrees. Look at the next pair. Here I see that 75 and x, the two rays that make them up, are vertical to one another, and therefore they are a right angle. So that's 90 degrees. So they are complementary. because they sum to 90, to get the missing x, I'm going to say 90 minus 75. Borrow from the 9, makes it an 8. 10 minus 5 is 5. 8 minus 7 is 1. The missing angle is 15 degrees. Okay, problem 5 shows angles that are vertical. These pair of angles are vertical. So they're vertical angles. So that's one piece of information. And since they're vertical, I said that they have to be congruent or equal. So I'm going to use that relationship to set up an equality. Let's get our x's on one side, because our goal is to solve for the x. So 3x equals 24. Isolate your x by using division. X is going to equal 8. Done. Now, they didn't ask you to solve for the angles, but we could have. This is 40 degrees, because 8 times 5 is 40. I know this has to be 40, so let's check it out. 2 times 8 is 16 plus 24, so that's 16 plus 24. Yep, it checks. It's 40. All right, so I didn't ask for that, but I could have asked for that. Okay, so this one says, find the measure of angles 1, 2, and 3 and explain your reasoning. Okay, so I would say that the 43-degree angle and angle 2 are vertical. Angles are congruent, so therefore angle 2 equals 43 degrees, and I'm going to write that right here. Okay, so that's one observation. Here's another observation. So far I have angle 2. I can say that angle 1 and the 43-degree angle are a linear pair. Linear pairs sum to 180. So over here I'm going to say 180 minus 43. That's going to give me, this is 7. 10 minus 3 is 7. 7 minus 4 is 3. And bring the 1 down. So that's going to mean that angle 1 is 137. Okay? So I'm going to write this down here. Angle 1 equals 137. And then angle 3 is also 137 because angle 1 and angle 3 are vertical. Okay? Okay, then it says identify a pair of linear angles. Well, I have several of them. So why don't I just name one of them? So angle 2 and angle 3 are linear angles. So these angles down here are linear. They're also supplementary, right? Because they're going to add up to 180 because they are a linear pair. Okay, so that was a lot of good information. Okay, now we have another figure. So in this figure it says, name the angles indicated. So what angles are vertical? You've got to be kind of careful about this. There's a couple of pair, but the pair that jumps out at me are these pair. This and this. Okay, they are vertical. They're across from each other. They're going to be equal. So those are angle EDB, EDB, and angles ADF. Okay, what angles are complementary? Complementary sum to 90. So I could either have which? Let's see. I could either have these angles in here. So this angle and this angle are going to be complementary. What else could I have? I could have this angle and this angle to be complementary because those two angles, they are adjacent and they sum up to the 90 degree. Okay, so let me get those marks out of the way. And so let me say, EDB, if they ask me for EDB, its complement's going to be EDC. EDC. And then what about supplementary? So they're asking about angle EDB. So EDB is right here. So I need it to be supplementary. So that means it has to be in a line. So what if I put it on this line? Then that would mean the other angle is this angle right here, BDF. So angle BDF. Those two angles are on this straight line right here. They're a linear pair, and they are supplementary. Okay, so then they want me to name all the adjacent angles. Okay, so there's a lot of adjacent angles here. So let's name a couple. So why don't we say the ones we just talked about as supplementary, EDB and angle BDF. Those are definitely adjacent. Okay, what else is adjacent? So how about the complementary angles? Aren't they also adjacent because they're sharing a common side? So angle EDB and angle EDC are adjacent. How about the big right angles? Angle ADC and angle CDB are adjacent. How about the bottom right angles? So angle ADG and angle BDG. Okay, so I'm not naming them all. There are more out there, but we certainly have the general sense of what adjacent angles are. So remember, they share a common side. Okay, so let's make some more notes up here. Okay, vertical, they're going to be congruent. Complementary, sum to 90. Supplementary, sum to 180. Okay, be very comfortable being able to give me that information in response to questions I may ask you on the upcoming quiz. Okay, so it says find the values of all angles if EDB is 30 degrees. Okay, so I'm going to erase everything I've done over here because what I want to do now is I'm going to fill in the angle they just gave me, EDB. If EDB is 30 degrees, that means that CDE has to be 60 because those two angles are complementary. If EDB is 30, then ADF has to be 30 because they are vertical. Who else is vertical? Well, CDE and FDG are also vertical. All right, what other angles do we have? Well, this box tells me this is 90. And since ADC and BDG are vertical as well, this is 90. So I'm going to say C diagram for all my angle values. Diagram. May I spell that correctly? And remember how important it is to label your diagrams because geometry is very visual. If you can put the numbers right on the figures, you'll be able to determine the values a lot better. Okay, so now we have some more questions. All right, so this says for number 8, find the measure of a complement of angle 1 for each of the following measures of angle 1. Okay, so if angle 1 is 68, complements add to 90, subtract 68 from 90. And that's a 2, this is an 8. 8 minus 2 is 2. So this has to be 22 degrees. Okay, if the measure of angle 1 is 80, and they have to add up, the pair has to add up to 90, then I can pretty easily say that 10 degrees will be the complement. Okay? Oh gosh, what if it's only 3 degrees? So then 90 minus 3 is 87. And so the complement would be 87 degrees. And to get the 10 degrees, I said 90 minus 80. And that's how I would get 10. Okay, so those are complements. So again, you've got to know that complements are 90 degrees. Because if you don't know that, you're not going to be able to attempt that question. Okay, then we move on to supplements. Supplements, you have to know, add up to 180. So let's take 180 minus the 78, and we'll see what we're going to get. So it looks like I'm going to get 102, right? So that's going to be 102. Okay, so that's 102, so that's good. Then we have a couple more here. So we're going to say, all right, if we look at this, if I have 155 degrees, 180 minus 155, that's going to be 5, that's going to be 7, that's going to be 2, so that's going to be 25 degrees. And if the angle is only 1, then the supplement will be 179 degrees, because I said 180 minus 1, and I would get 179 degrees. Okay, so put your degree symbols on everything. Name 2 supplementary angles to DOE. So where's DOE? That's right here. So what's supplementary to DOE? Well, if I go this way, that's going to be a supplementary angle. So that's angle COD. Or I could have gone this way, and that's angle AOE. Okay, next, name a pair of complementary angles. So if it's complementary, they have to sum to 90. So let me get rid of the marks I just put. Let me show you something. Do you see how this box is 90 right here? Well, this is also going to be 90. So a pair of complementary angles are going to be angle BOC and angle COD. Okay, what about vertical? So let me erase what I just had so I can illustrate vertical for you. Okay, vertical have to share a vertex and have rays that extend in opposite directions. So let's see, I have this. That little X gives me rays that extend in opposite directions, and therefore those angles are vertical. So it's angle COD and angle AOE. All right, so those are my vertical angles. Okay, it says A and B are complementary if the measure of angle A is 3x minus 8 and the measure of angle B is 5x plus 10. What's the measure of each angle? Well, if they're complementary, the angles have to add up to 180. Excuse me, 90. 90. This is 90. Okay? So if I know that, I can create an equation which is key to solving this. Okay, on the left side, you're going to combine like terms. We have a 3x and a positive 5x. That's an 8x. Then I have a negative 8 and a positive 10. That's a positive 2. That has to equal 90. Subtract 2, and 8x equals 88. Divide by 8, x equals 11. Now you have to find the angles. So this is 3 times 11 minus 8. So that's 33 minus 8, which is 25 degrees. Okay, angle B is going to be 5 times 11 plus 10. That's 55 plus 10 is 65. And do these sum to 90? Yes, they do. So I know I have those correct. Okay, let's do the next one. I'm going to set these guys are going to be supplementary. So if each measure is given to me and the angles have to be supplementary, I can also come up with an equation. And that equation, I'll change color for contrast. So that equation is going to be 4x plus 9 plus 8x plus 3 equals 180. Now, many students make the mistake of setting those two things equal, but they are not equal. So let's add our like terms. That gives me 12x. And now we're going to add the numbers 9, 10, 11, 12 plus 12 equals 180. Subtract 12, subtract 12. That's going to give me 8. This is a 7. That's 6. That's 168. Okay, so that is my value for what 12x has to be. So 12x has to be 168. So if I use my calculator, say, for example, 168 divided by 12, it's going to give me 14. So x equals 14. So this is 14. 4 times 14 plus 9 will get me angle Q, and 4 times 14 plus 9 is 65. And then for angle R, 8 times 14 plus 3 gives me angle R. 8 times 14 and then plus 3 more gives me 115. And these two need to add to 180. Okay, last thing I want to do here is talk about measuring. So you're going to measure, you're going to read this information about protractors, and then I'm going to measure on top and also tell me what the classification of the angles are. So this is what I have. If this is 40 degrees, I'm going to start here, okay, and go to here. That's my 40-degree angle. That's acute. Okay, it's cute and little. 80 degrees. I'm also going to start here, and I'm going to go to here where it says 80. That angle is 80 degrees, also acute. 100 degrees. I'm going to start here. I like to do open right angles. I'll change it up next angle. That's 100 degrees. And that is obtuse because it's greater than 90, less than 180. Here's 140. I am going to, why don't we open this way? If I open this way, I would then read the top numbers. That looks like it's greater than 90. It is. It's 140. That's also obtuse. And here come the last two. So I'm going to have 140. Well, actually, this is 140 again. That's not good. So, well, we'll just do that again. Why don't I do it in the other direction? That's a good idea. Come here and then go this way. This angle right here is 140, and I said that that's obtuse. So I just did it from the other direction. 160, I think I'm going to do it, start from here and go to here where 160 is. I'm reading the inside. That's obtuse. And now I believe we have two more. Okay, 90 degrees is going to be straight up like that. I'll put a little box there. That is right. And last but not least, the straight angle is right here. I'll put this little half circle there. And that is a straight angle. And that completes this. So go back over this really carefully, and you will do great on this assessment.